Aaronson Oracle is a statistical method for predicting future player inputs from his previous inputs. How does it do it? Well, basically, we put enough data in it and it predicts our patterns. It finds out what we press the most and it predicts what we will press next based on that. So let's see it in action. We need to press left and right as fast as we can. So let's press it, and the more randomly you press the buttons, the less accurate the Aaronson Oracle will be. Basically, it's based on the fact that human input is not so random if you are not focusing on pressing random keys and changing patterns. We fall into a pattern, and if we press one key very long time or the pattern very long time, the Aaronson Oracle can get very high accuracy. We will try to implement this algorithm in Unity into a game. So this is our little game. Let's play it. We have the same type of movement when another fish is mimicking our movements from what the Aaronson Oracle gives it. And you can see we can lose in this game, but that's not the point. The point is that you need to input something, because otherwise the algorithm has no input and cannot predict anything. So let's see how the enemy reacts if you fall into pattern. As you can see, the accuracy is very high and the fish keeps on repeating what we do. If you're interested in how it works, I'm Peter and welcome to Sunny Valley Studio Tutorials. This tutorial is made from two parts. First part introduces the Aaronson Oracle algorithm and prepares the setup for the algorithm itself. And the second part will present the code for the algorithm. So if you feel confident, you can just skip to part 2. So the theory. Aaronson Oracle creates a 32 sequences of possible inputs. Well, the sequence contains 5 consecutive inputs. If we input 5 inputs, we can predict which will be next. And this is based on the fact that each sequence keeps a score, how many left presses were there and how many right presses were there. To calculate how many sequences are there, we use variation with repetition. And I only know the name because of the hackmath.net, so you can visit the site to check it out for yourself. Basically, the order is important because each sequence must have a unique order of elements, and repetitions are allowed. So basically we have 2 elements and those 2 elements can repeat, and each sequence needs to be different from one another. So having those 32 sequences calculated, we create from them a structure that each sequence have number of left presses and number of right presses. If we have a bigger number of left presses, each prediction for this sequence will present the prediction as left press that will be next. And on the other hand, if this would be bigger, the right press would be predicted as next. But there is one catch. After each prediction, we compare the prediction with the input that was presented, and we add 1 to the valid input. So if user pressed right this time, we add 1 to right. And if those are equals, then we need to choose randomly which one should be given as the output. So basically that's the theory about this. Let's dive into the code. The link to the project files and to the Kenny assets that I'm using in this tutorial will be in the description. I just want to give you an overview of what is in this project, because I'm pretty sure you can set it up and make the player and enemy yourself. Let's start with the player. Player has player controller and the input predictor, the script that we will use for predicting inputs. With that out of the way, let's dive into the code. So first of all, we should take a look at the player controller. It has some code here, but the most important for us is our input predictor. So we get the component from our game object in the update. First of all, we need to check if player input is greater than 0. So are we giving input to the game? And if the last input is equals to vector 3.0. Last input is player input from the last frame. And because Aaronson Oracle needs single input for every stroke of the arrows, we need to ensure that after pressing the arrow, the user takes away the finger and press it again. Because otherwise we will get the continuous input and it will distort the accuracy and will not allow the algorithm to work. We take the time from the last stroke because we always need the player to input something. We constantly need him to input, even if it is in intervals. And that's how the player fish moves back. If the player doesn't provide input, the fish moves back and eventually you lose the game. At the start, we need to prepare our input predictor. We give him a first input from the player and we figure out what it was. It was up arrow or left arrow or right arrow. And because each input is either -1 or 1 if you get raw input, we can then set a positive and negative input as the two different inputs that the algorithm takes. That's out of the way. We create also here the 32 sequences and all the rest, and even give a random sequence for the predictor of the early inputs. So we randomize the input for the first time and then takes player input as for the next prediction. As I said before, we pass movements vector, so last input to last input variable. And we also need to control our enemy. First time, when we have no prediction, so at the first frame when the player didn't give us anything else yet, we set the enemy movement to the player input that was in this frame. So it is a little bit cheating, but from that point we always give the enemy prediction from our algorithm. To get the prediction, we call input predictor.prediction next input and we pass the current input from the player. And we move our player, and if our player is not inputting anything, we make sure the player provides input by counting the time from the last input and backing up the player avatar in case the player doesn't provide any input.